please welcome Sonal.
So, can you hear me? So thanks for coming over. It's been a great 2 days learning about the awesome work being done, and I'm thrilled to have met a lot of wonderful people. I hope you've had fun too. So my talk today would cover our real-time fuzzy matching engine Reifier and how we are leveraging Spark and Elasticsearch for Reifier. So stepping back a bit, who are we and why are we doing this? We are a startup from India. We like to dream big things. We want to defy the odds. We love challenges and tough problems. So the problem that we're trying to solve, business data is growing. And as analysts and data scientists responsible for collecting, organizing, and analyzing this data, we know what a mess it can be. According to Gartner, businesses are losing up to 25% of their revenue, of their potential revenue, due to lack of a holistic multi-channel view of their data. 67% of data scientists cite cleaning, organizing, and linking data as their most time-consuming task, and 52% of data scientists cite poor data quality as their biggest challenge. Now, as we accumulate data, duplicate data is amongst the most fundamental challenges that we encounter when we break the silos, the data silos, and create the data lake, when we want to match one with another, when we want to find one single source of truth. And that's the problem we're trying to solve. So why is this tough? Why is the problem that we're talking about tough and challenging enough for us to start attacking it? If you compare every record with every other record, if you look at just 1,000 records, that makes it about 500,000 comparisons to be made. We also have poorly or partially populated fields. There are typographical errors. Names, addresses typically spelled out differently across different records. Within a field itself, data may be swapped out or ordered differently, say first name, or last name, first name. So each data set has its own challenges and its own story to tell. Now, where is this needed? I mean, why are we trying to solve this problem? This problem is applicable in various scenarios. And the most common case that we see is that of customer record consolidation, customer account consolidation, or customer record deduplication. So if you see here, the records here have fields with typos, making comparisons difficult. Also, across the entire data set, different records will have different variations across combinations of fields. Sometimes first names may be missing, sometimes last names may be spelled differently, street addresses may be off, the state codes may be wrongly entered. And this makes it very hard to define rules which can cover all the cases. Another use case that we see is in comparing data across different sources. Now this gets challenging as fields are usually not very well defined. There are various omissions, like FaceTime is present in one of the data sets, smartphone is present in the other one, gray is spelt differently in both, and this makes it difficult to match them. And there are a whole lot of use cases of this problem across industries. So basically anywhere we are collecting, collating, and linking data. Now, if this problem is cross-domain, why don't we create something that can handle the different types of data? Names, addresses, products, vendors. Also, we want to work with large data sizes because that's what we see currently. We don't want the user or the programmer to have to define any rules or algorithms. Let the system be smart enough to figure out what is matching and what is not matching. An ability to support different languages would be nice too. Different languages have different challenges. Chinese names are short, English names aren't that short. Asian languages, Hindi and other languages, regional languages have their own challenges. So, and then on top of it, it'll be cool if we can, just look at all the existing data that we have, and when a new record comes in, immediately spot on whether there is a duplicate existing or not. So that is the real-time portion. So if we want to support, like you looked at the wish list, and if we want to support the different variety of data, work across multiple languages, not define any rules or algorithms, a cool way to do that would be to learn from the data itself. So our goal is straightforward. What we want to do is, we want to do only limited comparisons. So we want to bring a broader set of nearly matching records together. And then we want to also understand what are the similarity rules from the data itself. So we actually point Reifier to the data, and then using some crude notions of similarity, it starts asking us to label data and teach it what we mean by something that is matching or not matching in our particular case. So if this is visible, here we have customer records, and Reifier is trying to find some probable matches. Records which have maybe one or two fields which have some overlaps. So we've just started, and using some crude notions, it's tried to spit out some records. The user is going to label this, and we will refine and train our model. So this gets fed back to the system, and using this knowledge, Reifier will refine its internal models and spit out some more probable pairs. Pairs it is most confused about, or pairs it thinks it will benefit most through user labeling. So as we label some data based on the information the user has provided, Reifier gets smarter and smarter. Here we've labeled about 35 pairs, and the system gets more and more intelligent about the kind of pairs it is now emitting out and asking us to label. So if you notice, it is covering more fields, it is covering more omissions, more typos, and more confusing pairs, like Kingston and Highton, Wilkie and Wickel. And then a few more rounds down the line, we see that it again starts covering more and more cases and more positive cases. Typically in the beginning of the labeling rounds, we will see a lot more negative pairs being emitted, because that's what majority of the data is going to be. And then later on, as it has collected and understood the rules and refined its models, it will be able to figure out more and more positive pairs and start asking us questions about more and more closer pairs, which may be confusing enough. So once we have learned what we wanted to do through the user labels, we have our models ready, we have our buckets ready, we can write those buckets to Elasticsearch and do real time. The benefit of using Spark is that we can use nearly the same code that we have been using for batch processing in real time. We just use the Elasticsearch integration and some of our custom mappings with the right output format and write the buckets to Elasticsearch. To support real time, we front-end the Elasticsearch cluster with a REST API, which can read in an incoming record and go into the cluster, to the closest cluster, apply the model, and figure out if there are any matching pairs or not. So when we look at what we wanted to do and our wish list, Spark kind of really shines because the framework provides us scalability out of the box. Spark's in-memory architecture saves us valuable time because we do a lot of field-level comparisons. Through rapid sampling, we learn how to bucket near duplicates together and how to compare within these buckets to say what's matching or not matching. And because learning is fast and Spark itself is fast, we can feed the user labels again and again and fine-tune the models that we're trying to build. We create custom partitioners and only make selected comparisons. So the earlier problem that I had mentioned, which is 1,000 records and 500,000 comparisons, we can break that down. And using our custom partitioners, typically what we are seeing is many times we are able to get down to 0.05% of the actual number of comparisons we would have had to make. So we leverage a lot of MLlib, and we also have our own custom algorithms built around it on top of it. And we can create and export our models. Spark's programming interface is neat, well documented, far better than a lot of other open source that we work with. And that enables a lot of rapid development for us. So I think using Spark has kind of been the biggest and the best architecture decision that we've made. And we're really grateful for all the support that we get on the mailing lists and otherwise as well. It's only getting better. We're really looking forward to using some of the cool features being rolled out in 1.4. So that's it from our side. That's our website. Feel free to get in touch with me if you have a problem with duplicate data, and we can help you in any way. Thank you.